Okay, so today I want to just review probably the easiest part of the solving quadratic stuff, and that's where we can solve by isolating a variable. So for example, something like that example right there. Here's a good one. So where we can point to a single x in the equation, if we can do that, we can isolate it, right? Before we jump into that though, let's just warm up with a real quick review of how we can simplify radicals. So what's our strategy if we start off with something like the square root of 160? How do we do that? How do we simplify that radical?
Find the two greatest common factors or something like that.
We get right, and then we started off by using our list, and then I made an adjustment. You guys seem to like it better if we use the factoring tree, right? And I get that. I think that's probably a good way to do it. So what are two pretty obvious factors of this? Doesn't matter which two you pick, but if the number's got a 0 at the end, it's divisible by what? What? 10, yeah. So there's an easy one, right? I mean, you can do other ones too. You could do 80 and 2, or but it's pretty obvious if it's got a 0 there that it's divisible by 10 and then 16, right? What does 10 break down into?
5 and 2.
And 16?
8.
8 and 2, or I could even do, and that would work. I could do 8 and 2, or I could do 4 and 4. I'm going to pick 4 and 4 in this case. The other way would work too, but I wanted to show you just a little trick, not a big deal. So then I can take the 4s. Those are done, right? I know that I'm done factoring a branch when it's prime. So 5's prime, 2's prime, 4's not though. 4 breaks into 2 and 2, 2 and 2. And then we got to remember the little saying, singles or couples go out, singles stay in, right? So we look for couples. And I would say put circles around couples and squares around singles so you can distinguish the two. So there's a couple, there's a couple, and here are numbers that are singles, right? So what's that tell us then? Couples go out. So I've got a couple of 2's, so I get a 2 outside. There's another couple of 2's, so I got to multiply by another 2, right? And then times the square root of, inside I've got a 5 and a 2, so I got a 5 times 2. So then that just simplifies to 4 times the square root of 10. Okay, here's my question. When I get to this point right here, do I have to split up the 4's?
No.
I don't, do I? I don't have to because they look like a couple right now. And if I get a couple, I don't need to go any further, right? In fact, it's better to get a couple of big numbers than a couple of small numbers, than many couples of small numbers. It's just a little bit easier, right? So I could recognize that that's a couple and those are singles. And then I could just write this in one step as the square root, or sorry, 4 is outside, that's a couple, times the square root of the product of all the singles, which is a 10, right? Let's do one more. How about the square root of 180?
10.
Good, we got another 10 there, don't we? So we can break that up into 10 and 18. 10 we already did, right? That's 5 and 2. What's 18?
6 and 3.
We could do 6 and 3. And then 6 breaks up into 3 and 2. Okay, and so now we got to find our couples. So we got a couple of 2's, and we got a couple of 3's, and a single 5, right? So what's our answer?
6.
6, good, because I get 3 times 2, right? Which is 6. Times the square root of 5. And I'm done. Okay, no biggie. So we got that. All right, so let's do a couple examples where we're going to solve the quadratic, and the ones where we can point to a single x so we can isolate. Remember that our strategy, if you're ever at all confused about what steps to do, if we're trying to isolate a variable, how do we use order of operations? Right, because we know whenever we're solving for a variable or isolating a variable, what tells us the order of steps? And the order of operations, do I do top to bottom or bottom to top?
Bottom to top.
Bottom to top, right, I reverse it, I go reverse directions. So I'm gonna do that, right? Okay, so then what's the first thing I've gotta do here?
Subtract.
Add, subtract, so I'm going to
Add 2.
add 2. So that's gonna give me negative 2x squared equals negative 144. What's next? So I get x squared equals 72, right? And on this one, it says round your answers to the nearest hundredth, right? So we would just go into a calculator, and if I do the square root of 72, I get 8.4852, etc. So to 2 places, what does that round to?
8.5.
To 2 decimal places. So the nearest hundredth, they gotta go 2 places after the decimal. 8.49, good, it's a 9 because the next digit after that's a 5, so it pushes it up to a 9, right? If it was less than a 5, I would just leave it, right? So 8.49 I'll use the approximately equal to because we rounded it, so we get 8 point, I mean, you wouldn't have to do that. On Moodle, you're just putting the number in anyway, right? What's wrong with that, though?
Got a or whatever.
That would only be partially correct. How come? No, we're just, that's, the number part is right. But if I have x squared equals 72, how many answers should I expect?
Positive, negative.
2, I need a plus or minus, don't I? Good. Okay, so whenever you are undoing a squared by square rooting both sides, remember, you gotta have plus or minus in your answer. And so in Moodle, I would have to put those in separately, like, right, I put in 8.49 and negative 8.49. Or, it doesn't matter the order, right? But I'm gonna put them in separated by a comma, because there's 2 solutions, okay? Okay, how about something like this? Same thing, right? I'm just gonna reverse my order of operations. So first thing, what do I do? Add 4. And sometimes people, okay, let's do that first, and then I'm gonna mention one more thing. So if I add 4 to both sides, I get negative 4 times the quantity, negative 4x minus 5 squared equals negative 576. Sometimes there's a tendency for people to want to do stuff on the left side like distribute or multiply that whole thing out. It's not what we're doing, right? We're trying to isolate a variable. So every step we do to get the x by itself, what should be happening to the left side of the equation? Well, it might be an individual step, but just in general, every step I do to isolate x, the left side of the equation,
Oh, you gotta get rid of it.
I'm getting rid of stuff, right? It's getting smaller. I'm paring stuff away or peeling stuff away from the left side to just expose the x to get it by itself. So everything I do should be making the left side smaller, not changing it in any way, just making it smaller, right? So first we subtracted the 4. What do we do next? Divide by negative 4 to get rid of the negative 4. And that's making it smaller, isn't it? I'm getting rid of stuff on the left side. So now those are gone, and I end up with, on the right side, I've got positive 144. Okay, what's next? Got to get rid of something on the left side.
Exponent.
The exponent. Good, I'm going to square root, aren't I? Square root both sides. Okay, so now I get, what do I have to do when I square root both sides? Okay, so the square root of 144 is 12.
Positive minus.
Plus minus, good. You can't forget that. Then next step,
Add 5.
add 5. Where do I put the 5 on this side? In front. I always put, whenever I add or subtract a number to the other side, and I've got a plus or minus, I always put it in front of the plus or minus, right? And then now we're to here. Last step, divide by -4. Okay, here's something else that's helpful. When I look on this side, I've got a plus or minus, but look at the numbers, 5 plus or minus 12. Those are just whole numbers, right? I can combine those. Those are, right, those easily turn into one number, whether I add or subtract, right? So then when I'm dividing the right side, I'll divide the whole thing by -4 because the top is going to simplify, right? And then all we have to do, now we've got our x by itself. On this side, I've got to provide two answers. If I use the plus sign, what do I get? I get x equals, what's 5 plus 12? Divided by -4. I can't reduce the fraction, thank you, sir. I can't reduce the fraction, and positive over negative is negative, right? So this answer is just going to be -17/4, right? What if I take the minus sign? Then I'm going to get, on the top, almost -7 over -4, which is what? 7/4. So those are my two answers, right? Okay, now let's compare that to a couple other things here. So all this stuff is reminding you here is that when you're inputting this into Moodle, right, using that algebra editor, you can't use the division symbol to create fractions. You have to actually hit the template. And you also can't cut and paste parts, which is inconvenient, but you just can't do it. Even if it looks like your answer's right, it'll mark it wrong for some weird reason. I don't know why. That hasn't been fixed. So let's look at a couple examples like this then. What do we do here?
Add 1.
Add 1. And that gives me 5x minus 3 squared equals -98. What's the answer? Look at the instructions here. What's the answer? About right there. No, I'm trying to solve for x. Next step would be to
N.
it's n. How come?
It's negative.
Ah, good, because we're interested in real solutions only, right? But if no real solutions exist, n or n, well, what's the problem with that? Yeah, I can't take a square root of a negative number, right? So I know I'm not going to get a real solution from that. So because that's negative, my answer's n. Okay, so that's a quick one. Okay. Now I only know that when I get to the step where I'm trying to square root though, right? Like for example, this problem here, well, what if I had, gosh, I picked the wrong one. What if I had something like this? What if I had -2 x squared equals -98? Is that n?
No.
It's not, because I haven't gotten to the square root step yet, right? If I divide both sides by -2, I would end up getting x squared equals positive 49, and so it's not an n problem, right? You can't decide if it's an n problem until you're to that step where I'm square rooting both sides. And then if I have a negative number that I'm square rooting, it's non-real, right? Does that make sense? Okay, so you gotta be a little careful with that one. Okay, let's try this guy here. So, we're gonna reverse our order of operations again. What's first? Subtract 10, good. Okay, so if I do that, I get, on the right side, I'm getting rid of that 10. I'm making it smaller, right? So I get 2 times the quantity 3x plus 2 squared equals 96, or 196, right? Okay, what's next?
5x
Divide both.
Divide by 2, good. I got it, and I'm trying to take stuff away. Every step's got to remove something from the left side. Okay, next step. Square root, good. So I'm going to get rid of that squared by square rooting, right? So then I end up with negative 3x plus 2 equals, good, I got to get that plus or minus in there. And now we got to take that 98, we got to use our factor tree. What do we get?
7.
7 is 1, you're right. You're right. Well, not everyone's going to see that so easily, though. If you're struggling to find an easy one, if that's even, what's one thing you know has to go to it? 2, yeah. So I could do 2 and 49, and then 49 is
7.
7 and 7. Good, so we get a couple of 7s, oh, that's it. We get a couple of 7s and a single 2. So what does this simplify to? Yeah, 2 radical, or 7 radical 2, right? Couples go out, singles stay in, so, right? Okay, next step.
Subtract 2.
So I subtract 2, I put the negative 2 in front, right? And then we'll just combine steps here. What's the last thing to get that x by itself? Divide by negative 3. Good, so that gives me an x on this side. Now what about over here? Okay, so this is a case where those numbers are not going to combine, right? So when I divide by negative 3, we want to do it separately. Divide each term by negative 3. And now we can simplify. So negative 2 over negative 3 is 2/3, good. And then what about over here? We get our plus or minus, but remember our rule. If we're doing plus or minus a number, is there any sense in making that number negative?
No.
There's not, is there? Because what if I've got like something plus or minus negative 2? Well, that doesn't make any sense. Plus negative 2 is minus 2, and minus negative 2 is plus 2, right? So you always, if you have a plus or minus, you have a positive or negative in front of a term, and you're dividing by a negative, just forget the negative. It just makes things more complicated, right? And we want the simplest answer. So we would just end up with plus or minus 7 square root of 2 over 3, right? So that's our answer, okay? Let's practice putting that into Moodle once, just because we got that issue with how using the templates. I want to just reinforce that once. So that's what we're going to input. So there it is. Now how do we do that? So if I pull up Moodle, pull up this sample question. There it is. So to input that, I got to do 2/3, but I can't use the division symbol. What do I have to do?
Template.
Got to hit the template, and then I can go 2, and then the down arrow jumps me to the bottom. Thirds plus template 7 square root 2. I can hit the down arrow to get to the bottom, comma, and then I can't cut and paste, unfortunately. I just have to do the whole thing again. Only with a minus sign. And that should work. Oh. What did I do? Oh, there. Okay, it worked. I don't know why it's been acting a little wonky here today. That works. Okay? Make sense? All right. I think you're good to go. So, all the reviews are up. Now this one I've got solutions up for everything. And so if you want to go back, like if you you wanna, prep for the test, I'll put up practice tests too, how about, so you can do those at home if you want to get some additional practice.
Oh, yeah.
If you get, like, if you've got an assignment that you've already started, and you go to a question, when you load it up, if it says, sometimes you'll see this, it'll say reload question. Lately, I've been trying to be more specific. It'll say enter, what I mean by that is enter a wrong answer, and then reload the question. And then what that'll do on ones like that is it'll give you the new version, it'll give you a solution at the end. Okay, so I would urge you to do that. All right, have at it. You can work. Or test if you want it.